This paper was not too long ago, but it's the continuation of a more famous work called rStar, which came out in August. Yeah, this is from the same people. I mean, some of the people have changed, but this is from Microsoft Research Asia. And that paper was remarkable because it had some like good results. Oh, sorry, someone asked me to record this. I just remembered. Won't say record on him. Oh, uh, yeah. And this paper was presented at it's sent to ICML and it has some good reviews. But today we're looking at the continuation of that paper. In this paper, the main claim is that they can match the reasoning abilities of GPT-o1 with a small language model with the size of 7B. And in some cases, they are claiming that in math problems, they're claiming that they are beating GPT-o1. How they do that is based on step-by-step verified reasoning trajectories generated by an MCTS algorithm and by training a process preference model. So they are moving on from the ORM and PRM models to process preference models. And by the end, they're suggesting this self-evolution recipe to train two models, which is one is for suggesting policies, and the other one is for preferring the trajectories over each other. By the end, they're claiming that they can increase the reasoning abilities of Quen Math 7B on math problems from 58% to 90%. And we will see if we agree with the claims in this paper. So yeah, the main trajectory is that now we are moving from system 1 reasoning to system 2 reasoning, and the terminology comes from Daniel Kahneman's famous book. And we realized that for models that do better reasoning, we need to spend more compute on the test time and generate more trajectories and see if we can increase the reasoning capabilities of our models through putting the compute on the test time instead of putting them on the train side. Yeah, this figure can explain this paper mostly. So the thing is that they have these math problems and they have the questions and they roll out trajectories out of that with a bigger model. We'll get into the details later. And they start with the Q values of the end result, and then they train a policy model to try to estimate these Q values, and then they do 4 rounds of self-evolution where they retrain the same models to get them better and better, and by the end, this SLM R4 is claimed to beat GPT-o1. So let's get into the details. Is this clear? Are there any questions here?
Sure. Can you explain the image, like the left part? So
Yeah, this part. Okay. I'm not sure if I should I do that now?
okay, yes, whenever.
Yeah. Let me show you the data set that they start from. I think that's a better start. Yeah, for the data set, they take. Oh wait, where is the data set? They take the most famous data sets, but they add the Olympiad bench on top of that. Like in their previous work, they didn't do this one. In this work, this is the new one. And Gaokao, like the Chinese college entrance exam, is a new one that they added. And they claim this to be a very hard problem and out of domain. I'm not sure if this is included in the pre-training data. I don't know why they are calling this out of domain, but I'm assuming it's not included in the pre-training data of the bigger models that they're using. Then they use GPT-4. So they use GPT-4 to augment this competition level problems and to synthesize new problems. And they use GPT-4 to filter what they have generated and to get the high quality data.
So how do you know if the solution is correct?
They don't. They take the better ones. But by the end, they reveal that there are some of them don't have a correct solution.
Sorry, could you explain a bit more how they use GPT-4 to augment the solutions, the problems?
That's a good question that I'm not sure about.
Probably they didn't invent that.
Hmm?
I think they didn't invent that. They refer to some
Yeah.
of the paper. But probably some from like, can you problem?
So they take statement and augment the statement, and then they generate solutions with the statement.
Yes.
So they don't use solutions to augment new solutions.
No, that's a good question.
That's a good question. I think they rely on GPT-4 to generate correct solutions because at the end there's a section that they realize like some of the problems, some of the labels are not incorrect. They can check them. But like at this stage, I don't think they check those. They only generate like 10 solutions per problem and then keep the top 3 consistent solutions.
And one more question. Do they say why they choose GPT-4? Like, why not choose models for whole model?
No, they don't mention that.
But this is interesting. Retaining only those with at least 3 consistent solutions.
What does that mean? That's a good
It
question.
means that if 3 out of 10 solutions are the same,
Yeah.
then it's probably correct.
Yeah.
The same answer.
Yeah, they end up with the same answer. Is that clear?
I don't know. Appendix doesn't show.
No. So they have maybe they have like how they have a couple of examples of how they prompt their models, but not for the generation part, if I'm not mistaken. Example reasoning trajectories, answering proof, problem solving. I think the details should be in those papers that are referred. Where was it? I think
it means that you have same solution. Like if you ask people to generate 10 solutions, you ask it 10 different times, and then it's very obvious end up doing the same solution.
There should be one answer to the solution.
It could be the answer.
Or they have to do some judge model, but we may they also judge in the first class.
Okay. So after this step, sure.
Question on the diagram, the first diagram, when you're training the steps, there's SLM, R2, R3. So basically you train and then you go back to retrain on during training time and then so basically the system 1 gets better.
So there's a difference between system 1 and 2. So now they're going to generate the trajectories and train on the trajectories. So they call that system 2. And this 1, 2, 3, 4 is like 4 rounds of self-evolution. So they train the same model over and over again.
So that means, so that means if you ask the model, give you the answer quickly because it's a system of answer.
No, it doesn't give you the answer. No, it still generates the trajectories. The data set is a trajectory, and it learns to generate a trajectory. But it generates the trajectory step by step, and on those steps, they can use the PPM model.
Yes, which gives you the solution that is generated by MCTS, and then you feed that into the original model, you get R2 and R3 and so on the rounds. Right?
I'm not sure if I understand it.
So there are two ways to generate the answer. One is to just system one, just of the answer. The other is the test time, which using the multi-code research. And so basically, when you're using the multi-code research, you're generating another synthetic data, and you're feeding that back into the system one.
I think we move on from system 1 right now, as I was about to explain. After this, everything is in system 2. So let's go through that, and if there was any more questions, we can come back to this. So after that step, we end up with 700K math dataset problems, and here we start to do MCTS rollouts with a big model, with a big they use DeepSeek, the 200 billion parameter DeepSeek model. So yeah, they use this huge model to generate this rollout, and they create.
What do you mean by generate rollouts? So you give it a problem. What does it do? It means step by step, right?
Yeah. So they have this prompt that explains how they're doing this.
What a powerful agent.
So yeah, basically they tell the model to generate a step-by-step answer, and they do all of this in the prompt. And they tell the model to embed these tags of like code is needed here, and this is the end of the step. And the solutions themselves, like the natural language of the solutions are start with a hashtag, which turns into a Python like comment. And then they ask the model to generate Python code for this solution or this step. And the way they prune their tree faster than usual is that they check if the Python code runs or not. Just based on that, they can prune some of the trajectories and not continue from there.
So you give it a question, it generates steps, and then for each step, it generates Python code, and writes end of step.
Yeah. And it does that like till the end. This is DeepSeek. So it goes till the end.
But now, what do you mean by rollout? It means you just run it to get one branch, right?
Yeah, but like they have 16 of those for each problem, or 8.
16 solutions.
Yeah, 16 rollouts for the same problem.
Okay, so it will become like very different. Yeah. It's not tree, right? That's what I'm trying to say. It's
it can be a tree. I'm not sure if in the first step they expand nodes, but after that they expand node. They choose one node and they decide to expand from that node and create more.
What do you mean by node? It's
one step. Each step becomes a node.
But when you say rollouts, you mean they do that incrementally, or they just?
I think for the first step they don't do that incrementally, but after that they do that incrementally, and by selecting the nodes.
Okay, so now that we are generating data, right?
Mm-hmm.
And in this data generation process, we don't create trees, we create sequences.
That's a good question. I'm not sure about that.
Maybe it would be probably just create the trees, but the reality should be.
Yeah, but you don't keep it as a tree, right? Yeah. So that's why this term rollout, and then also need to think about the tree, but probably there's no tree there. It just creates regular SFT data, like regular end-to-end sequence from problem
I used to remember
Two solutions. Two sequences of. Imagine the one that's going to three, and they can be wrong vice versa in the first branch of the tree. After step one, you generate step two. Then in the second branch of the tree, after step one, you generate step three. Then after step three, step two, and so you get this binary tree. Okay.
Yeah, you could create tree, but I don't see it here. It looks like it gets.
Yeah, I get your point, but the way they say 8 rollouts and then MCTS, that's not clear how they do that.
Showing them too. Yeah, MCTS.
So by doing this, they're creating data of trajectories to train their small model, which is like still 7B, on these trajectories.
Okay, so where is that? Sorry, you had this initial trajectory generation that was a lot.
To enable SLMs to self-generate reasonably good training data, we perform a bootstrap round to fine-tune an initial strong policy model on this. So they're on this to collect the SFT data. And then
there is no reward model, so they just do SFT, they just write solutions one next to each other. We use definite value implementation to values of correct solution of two trajectories with the highest identity values are selected as SFT data. Okay, so probably it has some trees. They just later select the good ones as SFT. Like you, I don't know how they do it. So this is like the problem statement. They give it to DeepSeek, right? And it generates multiple step ones. Then they do multiple step twos.
Yeah, I'm thinking that could be the solution, but like when they say 8 rollouts, that's very limited.
Yeah, so they do it very
from each node 8 rollouts maybe, and each time they keep.
But somehow they I don't understand how they specify the Q values. When you do rollout and you reach the answer, like this is the answer.
Then you need to have visited each node a couple times to have some Q values, right?
You assume that all these answers are correct?
No, some of them are not correct. Some of them are not correct. I think from each node they expand 8 rollouts.
And in the end, it says that the top 2 trajectories, like maybe this one was good, and then this one was good. We keep these 2 as our training data. So we use MCTS inside DeepSeek to generate a lot of options. Somehow pick the best ones. I don't know how Q values work here.
The Q values are generated like this. But yeah, this is the description. By the way, this was interesting. They only have 4 800s.
Oh.
So yeah, they say why did they choose MCTS, and then they try to explain how it works. So X is the problem, and S is each step. SD is the final step.
So this is the trajectory. Problem, step 1, step 2.
And there's this code augmented section to it, which is like basically there's Python code to each step. And if the Python code executes, they assume that that's at least a healthy step. Like it's not too bad. And they keep those. And then candidates that execute successfully are retained as valid nodes and scored by the PPM. This is for training the PPM. No. So initially they don't have PPM, and their PPM for the first round is not good enough. So they just use the Q values in the first 2 rounds of that self-evolution thing.
When the first 2 rounds, when PPM is unavailable or is bad, we use terminal guided annotation. Let's see what it is. I don't understand this word.
Outcome award more.
Yeah, this is the at the end if they see there's a good solution or bad solution. This is the outcome of the trajectory.
Of the next paragraph, sorry. And
Following AlphaGo, we score each intermediate node based on its contribution to the correct answer, where the initial value is 0. Follow this step. We can leads to a correct answer. Its Q value will include otherwise between terminal nodes are supposed as 1 for correct answers. How do you know if it's correct or not?
You have the data set.
That data set, they start with math and they augmented it, and some of them are not correct actually, but you consider.
Okay, so these 700,000 questions that they had, they have answers.
Yeah, they have answers.
Okay, so okay. Okay, so you put each of these 700,000 questions, you do this 3, and then you end up with answers.
Yeah.
And then some of them are correct because you know from the data set, some of them are incorrect. And then you do this the propagation of MCTS. You assign some scores here. And then in the end, you take, I think after this backpropagation, you have also some forward thing. How do you keep the trajectory?
The ones that have like a better average of Q values.
Average of Qs.
Yeah.
So you take Q of these, Q of these, and Q of these. You take the average, that's the average Q of the trajectory. And then you take the best 2 trajectories and say this is my correct. Okay, so I don't have supervision here. I have supervision here. So if incorrect steps could lead to correct answer, then I keep them. It's the wrong 1, 2, 3.
Sequential, like they come after each other.
Round 1.
You have to train everyone.
Yeah. Yeah, you have like a policy model and a preference model. And with that preference model, you train the round 2 policy model. And we will get into that, but like No, you used that round one to generate policies.
Yeah.
And you use the preference model to generate better policies. And then based on those trajectories, you train another model, round two. You do the same thing.
We never go back to round one.
No, no.
Okay, I think I'm starting to understand what's going on. So in the initial step, your only supervision signal is here, which means that intermediate steps cannot be really scored. You just hope that if it gave a correct answer, I don't know, if this node gave to 10 correct answers, then its Q score will be higher. So hopefully it's a correct step. But that's your first approximation.
And also you have Python checking every step.
And then you have Python check to add another check. And then you can use this data to collect good trajectories and train your first model. And then you can also use this data to train a preference model that would predict your Q values even before.
It doesn't predict the Q value, it's a preference model. So it prefers one step over the other.
Okay.
So that's the trick.
Okay, and then does it explain how it is trained?
Yeah,
Or it's,
yeah.
Okay. I think it starts to make sense.
For each step, this is the natural language part of the solution, and they put it as a Python comment, and they ask the model to generate a Python code for that too. So yeah, in the prompt, they're like, let's think step by step, and whatever you think of, put it in a comment or like after a hashtag, and also generate the Python code for that. That was in the prompt. Huh? So this is the Python code. Like calculate the total distance walked south. Total south, 0.5 plus 0.5. And they just check if this Python code executes or not. That's it. They use the Python code as a verifier for the bad ones, but it can't tell if it's a really good one. And they assume that if this code executes, then this step was but not terrible. Yeah, a heuristic to take out the false negative, like true negatives. Yeah, if it's like too bad. Like in our case, it can be like something like the QED. Like if the QED of your molecule is like way too bad, don't continue that. That's a good. But they also have Olympiad level math. I don't. Yeah, I don't know how. Yeah. Let's see if they have one of the theorems as example. Oh, this is like algebra.
And also, I saw somewhere that it includes things like red and single is not. Oh.
Oh,
They have ablation without Python.
they don't have that much ablation, to be honest. Their ablation is just like these few prompts. What is this one? Problem solving.
Not this one.
Which one?
One that was simplified with the previous one, the previous question.
This was the
I think
this
yeah,
one? Okay.
So here for step 3, it does not have any Python code, but it's still continuous. So this is correct output. They claim that this is
Yeah, having a Python code is not mandatory. Python code is just to take out the bad nodes.
So they won't use Python only for the calculations.
There is no calculation done by Python. If the Python code executes, that's enough. They don't take the results of the execution. They just use that to verify each node.
Really weird, because if it executes, you better take it.
But you don't know if it's correct.
No, it's not. The same thing goes for natural language. So if it can produce something in natural language and then it can write code for that, and that something is very simple, usually taking the answer of the Python code does boost your reasoning ability, because you don't have to do the calculations.
But what can you do with those results? Like, imagine here,
And
this case, I don't know.
no, here you cannot use a Python code, but for example, if you have some division and you don't want to, I mean, you want to execute that with a Python code, so you can do like 5 ways. So if it writes Python code and then it executes the Python code, you want to take that answer.
But what do you do then with this answer? Like, we have 2.5.
Okay, all the steps that you do in the calculation. So I mean, it should have done the calculation inside itself, right? But now you take that part, you don't allow it to do the calculation.
Well, you kind of
In the language model, and then you just keep the output of the Python.
teacher force.
Yes.
Yeah, I think what you're
Yes,
saying
yes.
would make sense, but I don't think that's what they're doing. Let's see.
Yeah, they don't manipulate the output of the language model or replace the value with the Python executed things.
Yeah, this is all they say. Python code execution is then employed to filter valid nodes.
That already says right there, you can check the result, because don't filter both of the first one, filter nodes. So you actually probably only recall it like in isolation.
Do they have any experience when they have this Python codes? So the results.
I think they do. Yeah. They have some ablation studies at the end. So
Okay, this is not really obligation with this each round.
yeah, but like then they do that. The effectiveness of self-evolution. To evaluate the effectiveness, you use the data generated. Something from software. So here they do one like random selection of the trajectories, but this is like way beyond that. Like they only use Python for this for the first step. So Python is not even used here.
They don't.
No. And I think they only use Python to reduce the noise of the first round. And after that, they throw that away.
People take similar moves, let's say they're actually semantically equivalent. How do you
Semantically? I don't think so.
Say there's total sum equals 1.2, maybe the variable name is different, but
yeah,
but that is essentially equivalent, only the name is different.
Yeah, they didn't mention anything, and I think they don't. Yeah, I think that one they do. Generate on what? So yeah, here they are comparing this to their base model system 1 performance. Is this what you're asking? Like, this is their best model with system 2. This is the base model, what they started from. with system one, so not trained at all.
No, I think the answer is that if you, instead of doing these clever things with MCTS, you would just generate solutions with DeepSeek and take some of the correct ones
And train on that.
and train on them.
So I think that's round one, right?
That's round one without MCTS. Because you still chose the better trajectories according to the scores given by MCTS, right?
Yeah. Yeah, they do.
I mean, at least they could do the first step, right? First round. Without MCTS and without reference model.
Let me see.
The first round is just you take the trajectories and you train your initial model on trajectory. You can do that without MCTS if you choose these trajectories without MCTS. You just ask the question and
Yeah, I think that they didn't do. They only do a comparison between the different rounds.
But let's get back to reference model.
Awesome. No? 700,000. They generate the problems. Like they have some problems from GSMK and they add, like they use GPT-4 to augment their problems. Okay, let's take a look at the self-evolution as they say it. They just assume that it doesn't indicate anything, I guess, but they just assumed that the big model was good enough to generate simple Python code for like the small steps. It can execute, but that's just what they didn't do. They wanted to better their language model without the supervision coming from the Python code.
If they check this Python code execute, right, and if it doesn't, then they cut this, right? But if the model is good enough, why shouldn't it execute?
Yeah, but that will be supervision from the bigger model. They don't want to get supervision from the bigger model. They're only using the bigger model to generate trajectories.
So they are using small model to write this Python code.
No, the big model, the DeepSeek model generates the Python code, but they don't want to use that supervision in training their smaller models.
So there's one small model without this execution filter.
There's a base model, QM7B. They're training this on the trajectories generated by the bigger model.
And then at the second phase, they are using this Python code to execute.
No, they forget about the Python code. From the second stage, they have a policy preference model. And with that,
which is also small, right?
Yeah, the same size. And
Here,
they don't use the Python code.
when you had this DeepSeek model, which is very large, and you generate these trajectories, you want to have ways to filter out bad trajectories. And one of the methods is to use Python code. So for each step, you ask DeepSeek to generate Python code. If it doesn't run, you drop this step. That's it.
Do they have a case study when the Python code that generated by DeepSeek doesn't run?
They don't show the examples now.
Yeah, because it doesn't really make sense that a very large model will generate a code that does not run. So at least do they have any numbers? How many of the solutions have dropped because of the
Just like one line of, I think one sentence in the transaction today. Maybe it's leftover from old code base.
But even if the percentage of those is really low, that doesn't matter much because it's just a very cheap verifier to drop the like very few lines that will go bad. So why not? Maybe, but still it's a very cheap verifier and they're doing 10 rollouts and getting one, so or two.
And then they just brought this Python code to train the base model, right?
Yeah,
So the base model doesn't see any pattern.
that's a good question. I'm not sure about that. Yeah, probably. It can stay, but
It can stay, yeah.
it can stay, but like just noise.
Noise.
Yeah, but it's tokens that you're spending compute on.
Yeah, but it kind of reinforces your statement in English, right? It's like when you say the same in two languages.
Okay. Yeah, we're still at round one. So we saw that they used DeepSeek to create these trajectories. Then they trained one SLM on these trajectories. And yeah, so they do the PPM also in round one, but it's not reliable since it's like trajectories are bad or the Q values are bad. So from the second round, the policy model, they changed the policy model to the 7B model that they trained in the previous round. And then they did again like MCTS rollouts based on that. And now they do 16 rollouts per problem.
They use again Quinn.
This is the first time they use the Quinn model.
So
No, they dropped
use Quinn.
the
So
DeepSeek.
they use the same model both for reward and for generation. For this
No,
trajectory
no, no, no,
generation.
no. They still use the Q values. They trained the PPM round one, but the results was not good enough to use that as a policy model, as a preference model. So they still use Q values for the second round. So now they are generating the policies with SLM round one, what they trained before, but they're verifying that with Q values. And from then, like after that, in round three, they bring in the PPM model. Is that clear?
When you say they generate policies, it's 70. The policies are not the same as the trajectories.
It is the same. Yeah, they use this model to generate trajectories. They give the problems. They're like, now the smaller model generates trajectories. And now they switch up to 16 MCTS rollouts. And like, I think,
Because this is a smaller model, it's cheaper.
yeah, but they mentioned that because of lack of compute, they couldn't do more. And they haven't a study that shows that the more they do the rollouts, the better it gets.
So it's so poor. No, they only use music in round one.
Mm-hmm.
Everything else is, that's why the title said.
Small models can learn. Yeah.
They initially gave you something from very clever model and then.
Yeah.
Self-improvement.
No, it's Quan pre-trained. The question that came up for me, and I don't have the answer for, is that do they keep training the same model? Like for round two, do they keep training the model from round one, or they trained the pre-trained model with the new trajectories? I don't think they mentioned that.
How do you train the preference model?
Okay, we'll get there too. Let me finish this round and
Yeah.
yeah.
Okay, so in second round, you still do not use the first PPM,
No.
but you continue to generate rollout, again, verify yourself
Mm-hmm.
and create new data for second training.
Or the third, like you're talking about this, right? So after this, yeah, okay, yeah. You generate with SLM1 and train SLM2 and PPM2. So from here, PPM augmented MCTS is being used. And
I think to answer your question,
Mhm.
if they still, why they trained PPM R1 if they are not going to use it?
Maybe for the ablations later.
If they start, I think PPM R2 is built on top of it, otherwise they would just.
Maybe for the PPM, but for the policy model, it wouldn't make any sense to just retrain on the same model over and over again.
Why?
Isn't that cheating? No.
I think they continue to train, otherwise they wouldn't even try to train the first one.
Maybe. Yeah, that's what I thought, but also like, I'm not sure.
And then in round 3, they already have the real PPM.
Mm-hmm. And also they say this sentence, leading to significantly higher quality trajectories that cover more math and Olympiad level problems. So I think by covering, they mean their accuracy on these problems goes higher.
Yeah,
Yeah.
so
Because like at the end, they use this kind of language that after 4 rounds of self-evolution, 90% of the math problems are successfully covered into the training set, which implies that they added them in the training set, but I think they mean they solved them.
what does table 2 show?
Table 2.
They solved it with with this system. So they got trajectories that lead to correct answers. And then it doesn't do correct answer, then means simply
This is amazing.
Yeah, the round 1 on Olympiad level is bad, but by the end it gets to
Round is
80.
like 20%.
what deep sleep was on this. All right, let's see.
It's not very easy.
No, there is no basic for the people because normally you get more credits.
Is it deep or it is after round 1? I think it is the model, small model trained on deep sea generally.
I mean, I'm under 100.
Oh, yeah?
Yeah, there was.
I didn't see that.
And this is all greedy evaluation, not like greedy generation.
That's a good question. They have an inference section.
We run multiple MCTS to generate candidate solution trajectories. For each problem, we generate 32 nodes at each step and use the PPM to score each node. Since the PPM effectively provides step-level quality evaluations, we limit MCTS to just 4 rollouts per step to update Q values. After completing MCTS, the trajectory with the highest PPM score is selected as the final answer. So this can be done once you have PPM. Before you have PPM, you can't do this.
Also, I missed this section. They have more GPUs. Like it takes them 2 weeks to generate the whole data.
2 weeks?
10 nodes of 8.
Okay, so this 200 gigaparameter model is very expensive. So this is the like the equivalent in our research would be the simulator. You run the expensive simulator once with 80 GPUs.
And also they're kind of deceiving because in the text they only mentioned this part, but now they have 15 of those.
That's not like you don't need more than 8 GPUs to run the DeepSeek model.
Yeah. Yeah. I mean, these days with 10 nodes in 2 weeks, doing 1 hour we can take.
Yeah, to answer your question, I think they take some of the stats from the papers.
So in table 2 versus table 3, do you think that this Olympiad range and this Olympiad level is the same?
That's a good one.
Probably not, you know?
No, because
I think these 700,000 math problems are kind of generated.
yeah, this is
And
this is based on their problems, and they have like leveled them, categorized them as like these problems are harder. But this is the official Olympiad bench.
Without, ever reading the DeepSeek model for this one. Or it's low cost, it's better.
okay, it means that.
Okay, but still there's this question. So, okay, they have this policy model, but how many ranges they pay on each generation?
At round 2, it's 16.
I mean, for inference, not or
Oh.
they use exactly.
No, I think right now, when I showed the inference section, right? That's what they were doing. So they do MCTS, they already have some policy model. In this case, itself.
Yeah, so for inference, they also use this.
Yeah.
And do they have data without the, so just like one regeneration?
Not sure.
Because again, this doesn't really make sense.
You mean about MCTS?
Yes.
Oh, that's what T-Bone asked earlier. I don't think you can find no MCTS ablation.
Yeah, maybe these ones are not.
Yeah, show the password accuracy when sampling 64 trajectories.
Whenever it says system 2, it uses some sort of MCTS.
But also system 1 is no MCTS.
I think so.
Oh,
System 1 is.
No, but this is the base model though. This is not trained on their trajectories. So when you ask it a question, it just tells you one answer.
Okay, so what is the difference between this 64 and without 64? The last 2 lines, I think that was written in caption.
Okay, I think without 61 is the greedy, like without trajectories, with one trajectories.
Okay. I think system 2 already means.
No, I mean like it generates one trajectory. You want to go back to that pass section?
yeah, that's 64, which you generate 64 times. You have to rank it somehow, and then you pass at picking the best one. And you sort all the answers. And you say, oh, okay.
By the origin.
No, so maybe when it's not 64, it's only 32.
Only 32.
This is nodes. This is nodes during MCPS. The 64 is you generate a full solution. Yeah. But also they say in an evaluation, you run multiple MCTS, so I don't know.
Yeah, okay, pass at one is the greedy. Fine tune policy.
Yeah, but if you have people in the content, so having to expect. Guiding, but you can generate just on trajectory. It's like a beam search. Guided by people. There are so many ways you can generate.
I don't think it's that, no.
Yeah, but clever.
I think this is what you're asking for, pass from greedy accuracy.
These are different base models. So this is 22.5 not but small. This is 22.5. This is 22. So okay, this is exactly it. This is probably not to use any type of space or whatever. This is just direct 3D answer of the solution. So if you start from this Quen,
Our policy model is the prime model that they
without MCTS, without using PPM, we just 3D generate the solution. It is slightly better. So a lot of the power comes from doing MCTS and leveraging the PPM, right? This 47 becomes what? 60 something? Yeah, 65. Yeah, okay, I think this 41 is wrong, right? This 41.6 that existed in the table below.
Yeah.
And this 64, I think I know what it means, but it's worth to say it's probably they just run 64 times, and if one of them works, it's like Oracle.
It's
Wait.
usually when you scale from one run to 64, that you get the better results than just sense.
What do you mean? Like, isn't this with 64 trajectories and guiding with PPM?
I think the one without 64 here also has PPM guided normal MCTS. This is just running the same thing 64 times, the entire MCTS pipeline.
That's one accuracy with sampling.
Then if any of them is correct, you score. And I agree with you that you would normally expect larger difference.
Then what is this? 9.
Actually, maybe it could just indicate that.
You have PPM there. That's what I say.
For how many trajectories? Oh, 64.
No, it's the MCTS with these 32
Okay.
branches from node.
Okay.
And I think here you just run the entire thing 64 times.
That would be.
This probably actually if they discuss the difference is very small between the last two rows. It probably means that if the model is capable of generating a coupon, then MCTS will find it.
Okay.
You don't need to rerun million times. Which is good in some sense. But in significant, I think they don't have that much. No, basically, self-improvement. You always something that is not from self. One piece of supervision that comes from a stronger model. Then the rest is what is it? Figure straight.
This one? Oh, okay, this one shows that the more sampling they do, the accuracy goes higher.
Something of what? Higher than one value. That once you have a source, clever source, and it's when the first step, when they use DeepSeek to generate these solutions, the correctness of a solution still came from GPT-4, right? Because
Yeah.
that's who generates this problem.
Yeah. And there's this interesting part.
Get something from GPT-4, then get something from GPT.
Yeah, that's why I said let's see if their claims are good enough, because they use Python and then a 200B model and then GPT-4, and then they're like, our 7B model is the best.
Yeah, let's today squeeze.
This is interesting. This is the fourth round, and okay, when they cannot. So for unsolved problems after 16 MCDS rollouts, we perform an additional 64 rollouts if needed, increase to 124, 28. So they increase the rollouts at the end, now that they have better models. And they say after 4 rounds, they could solve 90% of the problems. And then they sample 20 problems and they find out that 19 of them were incorrectly labeled. So they just stop training. I think this is the GPT generated part.
Okay, let's understand this again. So let's say meaning we manually review random sample of 20 problems.
So like 10% of the 700 were not, yeah. Like they have like 700K, no, 70K. Like 10% of them.
Of the not solved
Yeah,
problems.
after 4 rounds, 10% of the problems are not solved. Like the system doesn't solve them correctly. They just sample 20 of them random.
Okay, so
It means that the problem is still not solved. Most of them, the solutions are incorrect, so maybe even the the answers are incorrect,
Yeah, the
so the
labels
original answers are incorrect, so even if it's solved, we wouldn't know.
Yeah,
But maybe the question is not solved.
yeah, that's the part that they don't open up. Like maybe the question that GPT-4 generated was a bad question.
Okay, so after fourth round, it would start to overfit on incorrect solutions to incorrect problem.
Maybe they didn't say that.
That's why we thought.
I think.
you said that they are comparing it with GPT, right?
Mm-hmm. Yeah, there is a table for that.
How do
They can do O1.
And they have one with GPT-4 too.
They don't, that's why it's a horizontal line, because they don't know how many evaluations they used. That chart we were looking at, when it's a horizontal dotted line, the reason it was horizontal is because we don't know how many used, right? We don't know how many times we actually sampled it,
This one?
because why would O1 not change? No, in the chart we were looking at, it was horizontal.
Oh,
And what is it, is this actually saying that no matter how many times you sample, it always gives the same result? I thought it was only don't know how many times.
say it louder, please. Uh-huh. I don't know that. I think this is best stuff.
This one.
One on what?
Like, we didn't repeat this experiment multiple times. With different
Oh.
seeds.
No, oh, you mean seeds? No,
Yeah.
I don't think so.
No.
I don't think anyone knows. Do we know? How big is O1?
Heard from Armin. Armin said that GPT-4 all is probably a huge visual expert, but every time, like, I don't know, around 30 billion parameters are used. For all.
Same as DeepSeek.
Could be, yeah. But how many each could be like in a larger picture? So for one could be, I think, if I was working there,
So I think in the GitHub repo of the rStar, they say that O1 is based on rStar to some extent.
Is it?
If you look at the GitHub repos. So, yeah. In their announcement, they are proud. Yeah, that's
the link right there.
This one?
yeah.
There's a bunch of papers here.
what I do recommend. This is not official, right?
Oh, I don't think this is.
Oh, it's just feature because
Yeah, maybe they know, but they cannot say it directly, so they write it this weird way that.
What do you mean it's based on? Like they got the idea from this?
Also,
I think
Yeah,
it's-
but didn't this paper come out before that? Let's verify step by step. This is from OpenAI, and here they talk about the test time compute and verification using ORMs or and PRMs.
Does this have, actually,
They don't talk about MCTS, but they talk about process reward models. No. But like they should have some trajectories too. Phil, would you know about this?
This is no MCTS is like.
Cool. Yeah.
Mhm.
Okay, I think the biggest question that remains is that how do they train the PPM? Right. Okay.
That's preference. So the most important part of this is how do you know in advance that when you are still generating the steps, we don't have the final answer. Can you figure out in the intermediate step whether this step is clever or not? Like when you play chess, you can do that by looking at the table that you have too many queens and you are good, right? But in reasoning, when you're trying to solve a math problem and they give you some intermediate step, it's hard to say whether it's good or not. So the magic of PPM is that it learns to score the intermediate steps. That's why it is kind of important for everything these 01 or 3 are doing.
So they say that they first use Q values, but the Q values are not very reliable. And they introduced this novel method. I'm not sure if it's very novel, but they basically take pairs of the nodes, like they take two good nodes and two bad nodes, like based on their Q values, like two that have like higher Q values compared to two that have less Q values, and they take nodes from the same trajectory, so they're the steps behind them is the same. Is that part clear? Like they don't take nodes from different trajectories of or nodes that have like their past steps are different. Yeah. So if they take two nodes to compare to each other, they take these two, let's say, not like this and this. Okay, that their previous steps are
So
different.
they take nodes with the same current.
Yeah, same trajectory up to that point.
Mhm.
And then they train this preference model based on Bradley-Terry model. And I think DPO also did this, right?
Yeah, everything is correct, and it's probably very model like KTOs.
Yeah. So I'm not sure what part of this is very new.
So the model should, what does it operate on? It operates on trajectories up to this point, right?
Mhm. Oh yeah.
When I
Okay.
did not the final answer.
Let me. So yeah, the PPM is initialized from the fine-tuned policy model,
Mhm.
and they just like replace it with a scalar head. Yeah.
Let's take the model that solves the problem. They add the single linear layer on top of it, which outputs a number, and they use parabolic tangent to move this number from into minus 1 to 1. And
And then after that, they just generate
yeah,
this.
if this node is better than this node, this linear layer, when it comes to here, it should give higher score for this one than for this one. That's it. Okay, so, and they probably backpropagate through the whole thing, so it's not only this layer.
Yeah.
That is all trained, right?
Yeah.
Oh, I thought you meant, are they calculating loss on the entire?
I think they do. No?
Should be good.
No, they should do it, but
Yeah, they add up this.
Oh, one, yeah, starting with one.
Yeah.
okay, so positive example is a trajectory up to this point where.
Yeah, and only their
negative
last
one.
step is different.
Yeah. And then they put it here. They do conductive loss essentially.
It's like DPOs.
Yeah. They essentially learn to score intermediate steps.
Mhm.
Then they use this to guide. We aim to this point that there needs to be something to guide, but didn't do that, right?
No. But we were already thinking of DPO. The problem is that our intermediate steps are not very verifiable. Like,
Well.
yeah, but the thing is that maybe half a molecule wouldn't show that property that you're looking for.
Yeah, I mean, from domain knowledge perspective, maybe you're right, but like from algorithm perspective, it doesn't show. You could still be different.
Yeah.
I see, but probably the point of this paper is to distill the power of huge models into small ones.
Yep.
Leverages, yeah, the multiple generation, to learn a lot more. In fact, I don't know where I saw that, but there are rumors that this latest Globe 3.5 is trained with registries. So
What model?
Globe, the
Oh,
latest
Claude.
Globe. So they say that probably Anthropic has an internal O1 model, which is not released to public, but they use O1 to generate data like this exactly, and then feed it to Claude.
Oh, and then Claude inference is cheaper.
Yes.
Okay.
Because I don't know if you've seen in this group chat and a museum, they usually ask, have you ever seen a problem for O1 words, but close to 5,000? Honestly, it tested a few of them. It didn't. Yeah. So it's possible that Cloud 3.5 has this O1 style power, but it is already distilled into the main model.
So one of the things that they found is that the model has self-reflection capabilities. Like when they realize they're not going down the right path, they can correct themselves. And they bring this example, which is a bit hard to understand. So they say the model has initially formalize the equation using the SymPy, the first three steps, which will lead to an incorrect answer if it had like gone down this path. But then in the fourth step, the policy model recognizes the low quality of its earlier step and refrains from continuing along the initial problem solving path. Instead, it backtracks and resolves the problem using a new, simpler approach.
So when you say backtracks, it's not the model, it's the
It doesn't-
that.
Yeah.
Well, the model just decides to generate that, right?
Yeah, so probably from this node,
It could generate
it
that.
would go this,
You go left, yeah.
yeah, it went left, it didn't work out, it came back and tried another node.
That is a really very.
I think it doesn't base its solution based on what it had generated on the third step. That's what they mean by backtrack.
Backtrack just means like, this was just useless, it was just like.
Yeah, like-
Backtrack this.
It generated these three steps and it was trying to like go down this path, but it realized like it can like
I see.
not use this and start all over again.
I see.
This is restart.
So this solution does not really depend on those.
No.
steps. It is different.
What did the more
Policy model?
Besides, that we should change it.
Mhm.
Because it's first generates some molecules and then use the higher PPM score and the E computer has PPM score.
No, but like the policy model should have the ability to generate this also. It's just that the PPM decided that let's go down this.
Yeah, when doing MCTS, I think from this node, it generated this and this.
Yeah, the point is that the policy model had the ability to generate this, which is like not based on previous steps.
Yeah.
But it's true,
Then the PPM tells like go down this.
This, go this way. So your point is that our model should also be able to say, or just the molecule that I was trying to construct, that's that construct.
Yeah, maybe.
Its PPM scores for the ones that it stopped generating are still negative.
Yeah.
So probably it will not change solution. Ideal solution, the solution is hard, but it's correct.
I'm not sure I'm following.
So here they claim that besides the fact that it changes to a correct solution, it also changes to a more like easier approach.
Uh-huh.
What I'm saying, probably it should not, it will not change to easier approach, like given the fact that from the beginning the PPM scores are high. So if the starting solution is correct, we can do that solution.
On the right way, independent.
Yes, either one.
If you want to do it.
This is definitely charity. I think this easy versus hard is subjective, right?
You need to get into the problem and see like what's the correct solution, what's the perspective, and which one is easy. But yeah. Not too bad.
Why wouldn't you, like, if you change your mind and go to a simpler solution, doesn't mean that, like, you understood the harder one, then chose the easier one, and that, like, if there wasn't an easier one, would you still choose an easier and wrong one than the harder and correct one? Like, if you chose the easy path, probably you don't even guess what could there have been the
Yeah, but what makes the
hard is weird. They just two cleanups going nowhere.
I think what makes the hard one more likely is that it's based on the first three steps. So it's more likely for the causal model to go after this.
The BPM model takes the steps. So the BPM model takes the statement and all the stuff generated by that point, then generates the score for the next. So for the
It takes two nodes, like it takes this node and this trajectory and generates,
what you say trajectory.
like it takes in all the steps that lead it to them.
So just the text.
Mhm.
So not previous scores.
I don't think so.
And also the statement or just steps.
That's a good question. The statement, you mean the question?
Yes.
Maybe.
It's always.
Yeah, it takes in the X. Yeah, but even the first models had this ability to generate step-by-step results, right? And they just use DeepSeek to generate step-by-step trajectories in a specific format.
I think that here the self-improvement part comes from the fact that initially there was a more clever source of knowledge. Like if I try to visualize this is like, I don't know, DeepSeek knowledge. And then I distill it in two directions. One is SLM, the other one is BPM, right? And then I use this way, kind of. So I have this, and the information from here can still improve 4 iterations here. Because I had like 2 channels of bringing in the information, and these 2 channels complement each other in some weird ways. But like if I don't have this, like, what is this for the largest O1 model?
Human annotation.
Human annotation and more round.
And
They did this with 700,000. Maybe that sounds wrong. Super annotated. Stay there, like. But it doesn't take the original part. When I compare it first, like for O1 or for O3, where does it come?
You pay for 700,000 for annotation if you're.
But they hire a lot of mathematicians, right? Who? Human generated.
No. They generate math problems with their solution.
Yeah, but like the first ones, they get humans to annotate them.
Yeah, but you could like generate from without even GPTs, right? You could.
When I was doing prompt engineering for scale, like maybe 2 months ago, they were doing like chain fine tuning with like math fonts. But like the model generates like 10 steps of like high school algebra or calculus, and then like the guy or any of the contractors like goes in, looks for like the wrong step, find the wrong step in between, and like write the reasoning for why it went wrong, like why did you change that step, and what correct thing you should take. I know that they're doing that just from work.
There you go. And the thing is that with this much money, like it's not that expensive to hire mathematicians. Sounds bad, but
CEO of Supermarket told me that one of their clients asked them to annotate, to organize annotation of some data. And the requirement was that the annotators should have 10 years of Python experience.
okay, this is the last figure I'll show. And this is uh-huh.
When you have this also K, and then you take this K large, the model starts to generate more solutions that actually work. So one of solving problem things could be that model just starts, so model is actually able to solve the problem, maybe by chance, because there's like temperatures like that. But when you solve improve, you just bring this to less process and finally to completely here. So that would be like self-improvement as well. But probably like having a lot of data, we are not yet, we didn't get people dealing with the models nice and available data. A small model. And especially for reporting the loss.
You know, my point is that for general, even if you have equally money to pay mathematicians and so on, you are, in some sense, you have an upper bound of human knowledge, right?
Yeah, but we didn't hit,
Yeah, but then if you can do this part, which is kind of the verification at human level, you can still, in theory, be able to generate better solutions than humans could generate. As long as humans can verify.
Or anything can verify.
Or anything can verify. Yeah. I think that's where the real magic is. And I don't think this demonstrates that.
Well, they do because they use the consistent solutions for before. That's the thing that is there. And that's the system. That's in that, that's going in that direction.
But they improve, right?
Yeah, but we don't know whether they reach this level or not. My point is that, like, you can say that DeepSeek has some expertise or some knowledge to solve the problem and to verify the solution. So I think this paper approximates DeepSeek's abilities to solve the problem. Like imagine you use DeepSeek as your verifier and you learn to generate solutions that are better than DeepSeek would generate.
Yeah.
That would be very interesting.
That's not work, right?
It might work. I think that was what I was.
Yeah.
What was it trying to explain?
Can you represent this all in kind of the non-like framework where they are getting each other somehow trying to.
Yeah, actually in their original paper they do that. They call it a discriminator. So this is the original rStar paper. So SLM1 is self-generator and SLM2 is discriminator.
Yeah, so Bright is saying that as long as you have a verifier that can verify solutions better than random, We
can
always
always
have an ability to create better and better generators, even better than your teacher, right? That's what I would love to see somewhere.
But in the, not sure past the
I don't know how that school is right?
We have this with system 1. Oh, you mean this?
Yeah, there was DeepSeek system 1, which is the best thing you can do with DeepSeek. Yeah. So it is like one generation.
Oh, yeah, they should all be past 1 accuracy, except the ones with the 64, which are like 64 trajectories.
Good point. Like if you ask DeepSeek to generate 10 solutions, then ask DeepSeek to write them or.
Yeah, that's what I was going to say, like generating and verifying, I think that's fundamentally different because there's one knowledge thing, but
Yeah.
generating some knowledge and verifying it, and
Do you agree that it's possible to squeeze more from this? That you could ask DeepSeek to generate million solutions, then ask DeepSeek whether this is the correct solution or not. Yeah. And then filter out and think.
Yeah, but that kind of that is based.
Without training DeepSeek.
Yeah, but like that's based on the fact that one of the random ones will be a good one. But if your search space is really big, like molecules, you need way too many random ones to have a one good one.
I agree. But my point is that this is probably not the full power of DeepSeek today.
Yeah, your concern is that they are not sure, they are using DeepSeek original model. They initialize like their models, but they are not showing that they are in the fact.
Yeah, because they are not interested in that, right? They want small models.
Yeah, but for example, if for the larger instead of the larger, they use. Yeah, probably.
Yeah, I think that if you, without training DeepSeek, do everything you can with a lot of compute, a lot of inference compute, you get some result, and then these models surpass that. Then it's you squeeze more than if you.
Okay, as the last figure, we can look at this. Uh-huh.
Yeah.
So this is an attempt to show the quality of the PPM and how much the PPM adds. So this light green colors is the policy model, but without the PPM. And the dark green is what PPM adds. And they are comparing this to Quen 72B. And these are past one, so I guess it's like greedy sampling.
Quite impressive it's obvious that when those who train when they put a lot of effort to have a mask specific version, and with 1.5 billion parameters, you get more than that. It's very impressive. The last part of this figure is fine, which regardless.
They just made it bigger, so maybe no one would notice.
Can you do this like step further? Like in any step, generation is this kind of standard thing for the token thing, right? We need the step how to generate the token.
This better choice.
Yeah, like in the box. Like each, no, a version is a text box too, right? Like you generate some Python code
I
using.
think that you ask it again.
No, how do you do it?
It's
How do you
coding.
generate the code?
Yeah.
Yeah, the coding, you still do no search 3D decoding, right?
It's not very good. I think it's not good.
You should sample or else they would all be the same. Like temperature. So
Yeah.
or you can do beam searching.
Yeah. And they don't, they have the thing.
They should have this somewhere. Hmm? Up?
Is it on GitHub?
Oh, maybe.
I've tried the link, I get an idea. Yeah.
Oh, this is the old one. This is the old GitHub.
Yeah. This only came out 10 days ago, so
No, but that's the old one.
yeah, probably they didn't have the new code base, so they just
This is not,
It's the same.
yeah, it's the same people,
okay.
but they still don't have the rStar-Math. They
Yeah.
only have.
I guess that link just means it's planned to be Microsoft.
Yes, someone.
There is a private now. Yeah.
The legal team did not allow.
Yeah. Some test that is my,
And you are the final approaching for the laptop.
I'm not sure.
1.5 yeah.
Well,
With the
no.
slow.
No, I think you could keep it free.
Slowly.
Yeah. No. And without being frustrated.
If you use LLM version. Temperature. Okay.
Oh, and beam search. You can do it on your own.
That was it.
I think this whole project to scale down to a token level and to kind of like any generation. Right, and for the next token, you do this two rating thing.
Yeah, you can do that. That's what we are trying to do, right, Tico? We are doing that based on tokens, and each node is a token. then you would have Q values, but then you need more rollouts to have better Q values. Yep, that's the paper. Can you stop the recording?